Hi there, Mr. Sutton here, bringing you this Pre-Cal Honors 511 lesson on double angle formulas. In this one, we will be applying identities for double angle trig functions. To start this lesson off, we're going to give you some of the double angle formulas. Don't say I didn't give you anything. So there's 5 identities for converting between single angle and double angle trig expressions, and here are the first 3. So for the first one, sine of 2x, sine of a double angle, we can rewrite that as 2 times the sine of x times the cosine of x. What's the big deal? Well, the big deal is that instead of a 2 inside the trig function, now we just have a single x instead of a 2x. So that might be helpful at some point. We also have one for tan of 2x. That's going to be a big fraction. It's going to be 2 tan of x over 1 minus tan squared of x. And we'll do one more here. Cosine of 2x, that one's equivalent to cosine squared of x minus sine squared of x. Now this one might look kind of familiar. You're like, hey, I already know an identity with cosine squared and sine squared in it. You do, but there's a plus instead of a minus in between those. So be careful, don't mix this up with that other one. Speaking of that other one though, here's where the warm-up comes in. Using the identity sine squared of x plus cosine squared of x equals 1, see if you can rewrite this cosine of 2x identity 2 different ways. One using only sine, or sine squared, and one using only cosine. Pause the video and see if you can see where I'm going with this. All right, so the way that I did this, since we know sine squared plus cosine squared equals 1, and since I can rewrite this as cosine squared equals 1 minus sine squared, I can use this fact that cosine squared and 1 minus sine squared are the same and plug in 1 minus sine squared to this identity up here. So instead of writing all this stuff, I'm going to instead write 1 minus sine squared, where that cosine squared used to be, minus this sine squared that was already in there. So what is this if I simplify it? Well, this is just going to be 1 minus 2 sine squared of x, which, I don't know, that might be more useful than having 2 trig functions in the same identity. Who knows? Now, the other way we could have done this, instead of subtracting sine squared from both sides in the big Pythagorean identity here, we could have subtracted cosine squared from both sides. Since sine squared equals 1 minus cosine squared, I can replace this sine squared up here with 1 minus cosine squared. Just make sure I put all that stuff in a big parenthesis so I don't lose anything. Simplifying this, we have a minus 1 and a plus cosine squared, so we can rewrite that as 2 cosine squared of x minus 1. So these 4th and 5th identities, these are just different versions of this third one. So sine and tan each have a single one. Cosine of 2x has 3. So you might be wondering how we use these identities in practice. Well, one way we use them is to take big, complicated-looking expressions like these examples on this page here and turning them into something a lot nicer to look at. So for example, this one, we have 1 minus 2 sine squared of 20 degrees. We're supposed to simplify this. Well, we have the identity that cosine of 2x equals 1 minus 2 sine squared of x. So we can think of this x as being just this 20 that's in this expression here. And instead of writing all this craziness, we can just write cosine times 2 times, or cosine of 2 times whatever's inside there. So I can convert this to cosine of 2 times 20, which I can just simplify to cosine of 40 degrees. So this looks a lot nicer than this craziness here. Pause the video and see if you can use the same kind of reasoning on these other 2 examples. Alright, so for this example here, we know that cosine squared of something minus sine squared of something is just the same as cosine of 2 times the something. So I can rewrite this as cosine of 2 times 40 degrees, which is just cosine of 80 degrees. And for this one, we know that 2 times sine of something times cosine of the same something is just really sine of 2 times the something. So we can write all this stuff as just sine of 2 times 10x, which is really just sine of 20x. So this really does come down to, do you recognize the pattern and remember that this and this down here are equivalent? And these often come up when you least expect them. If I'm being honest, this one comes up more often than the others. We'll do one more problem for this lesson. Pause the video and see if you can simplify this thing. Alright, now hopefully you remembered that 2 tan of something over 1 minus tan squared of the something is really just tan of 2 times the something. So we can just rewrite this as tan of 2 times pi over 8. Well, what is 2 times pi over 8, that's just going to be 2 pi over 8 or pi over 4. Now here's where things get a little trickier. They said simplify the given expression. The expressions on the last page, we couldn't really break it down any further after we got things simplified like this. But on this particular problem, where we have tan of an angle that we know the tan of, we actually have to go a little bit further because we can. So what's tan of pi over 4 or 45 degrees? Well, you might remember that that's 1. It's the sine of 45 over the cosine of 45, and those are both the same thing. So this is just 1. So that's it for this lesson. As a wrap-up on this one, here's a nice little Quizlet you can go to study these identities and make sure you're ready to take them out whenever you need them. Until next time, Mr. Sutton signing off.